Hi, Prakhar.
Hey, hi. Let me ping once in the group, and then we'll start.
अब लगा दी ना ब्रेंडो फिर बाद में कर लेंगे
think we completed everything on the HLD side, and we have to start with the LLD today. Let me just take a look very quickly. Just give me a second. Okay. Cool. So we'll start with the database design today. I hope everyone can hear me very clearly.
Yes, Prakash.
Let's try to understand how to actually design the databases. I've seen a lot of people struggling with databases. So we'll try to understand the basic concepts of database design. And based on that, we'll again pick up some of the problem and try to come up with a solution for those. So, there are 5 parts of database design. So first is, let's go through each of these five parts. Let me start sharing my screen. Let me know once you can see my screen. So the first is, so whenever you have to, actually design the database for any of the design questions. So we are starting with the low level design now. The first part you need to do is you need to identify the entities. Once you identify all the entities, you need to figure out the relationship between those entities. Now there can be redundant relationships. So we'll see how there can be redundant relationships. So if there are any redundant relationship, then we try to remove those. For many to many relationship, we create an association entity. I'll explain you what is association entity in some time. And then finally, we do a normalization of the data. So normalization, what is normalization? It's a process of organizing the data in the database. It is used to minimize the redundancy from a relation or a set a set of relations. It is also used to eliminate undesirable characteristics like CRUD operations. You don't need to like insertion, updates, and deletion anomalies. We'll go and understand how this will work. Normalization divides the large table into smaller tables and links them using the relationships. The normal form is used to reduce the redundancy from the database. Let's try to understand what does all of these things mean. So let's take an example. Let's say that we have to actually design a table where we have to design the tables for the e-commerce platform. Okay. So what is the first part? The first part is to identify the entities. So let's identify all the relation entities in this one. The first part is identifying the entities. So for identifying entities, what do you think? What all tables will be there? Let's start figuring out all the tables. So the first table is the customer table for sure. There will be a seller table for sure. I hope everyone can see my screen, right? Yeah. So we'll have a customer table. We'll have a seller table. What else we'll have? We'll have a product table. What else? We'll have an order table. We'll have a transaction table. This for the e-commerce system. We are saying that we'll design a e-commerce. Is there any other table which you can think of?
Reviews.
Reviews table can be there. Yeah, reviews table can be there. Very correct.
Order history.
Order history you can maintain just to, I mean, we can say that it's okay. We can skip that one. You can have another column called order status history in the order table itself, and you can maintain it, not creating a separate table for that.
Maybe returns.
I mean, yeah, let's not go there for now. Let's say that these are the only available tables for us. Now let's try to identify all the relationship between these tables, right? So the second part is what? Identify relationships. Okay. Let's identify the relationship. So what are the, so can we say that customer is related with order? So one customer can have multiple orders, right? One customer can actually order multiple products as well. Can I say that customer and products are also relatable? Similarly, seller, an order can be placed with one of the seller. A seller can sell multiple products. A product can be sold by multiple sellers. Correct. A product can be sold by multiple sellers, and a product can be sold by multiple sellers. So we'll have a seller, we have a product, we have a product, we have a seller. Correct. And basically customer to order, customer to product, seller to order, seller to product, product to seller. Then what else we can have? So we have transaction. So order can have transaction. And customer can add a review. Correct.
Customer can be seller, seller can be customer.
No. Okay, so seller is a separate platform, customer is a separate platform. Customer is a customer, seller is a seller.
Oh,
I'm not talking about the account. These are two different identifiers altogether in the system. Okay, so these are the relationships which we have, right? Order, product, product and order are also associated, right? So one order can have multiple products, and one product can belong to multiple orders. Right? So these are the relationships which we have identified. Then the third thing is to remove the redundant relationships. Let's try to see what are the redundant relationships here. So can I say that customer is associated with everyone, let's stay on the mute, stay on mute, please. Please don't unmute yourself. Thanks. So now we have to remove the redundant relationships. So see, one customer is associated with order, and order will have product, right? So we don't need to associate customer with product separately. So can we say that customer is associated with order, and order will have multiple products? We can strike out this relationship altogether, right? Okay. Similarly, one seller and order will have to have it because different product can be sold by different sellers. Either we store the product ID, so we can say that if we don't want to store the seller ID in the table, then can we say that order is associated with product and product is associated with one of the sellers. Now seller is associated with one product and product is associated with one product can be sold by multiple sellers, right? So either we'll have to create some, so see, one seller can have multiple products. So one product can have multiple sellers. So we can't say that, we won't be able to identify like how many quantities, like this product is sold by this seller and this seller, but we can't store the seller ID in case of product, right? So we'll have to create an in-between table. So can we say that we'll create another table called item table, because this is associated with this, and this is also associated with this. There is an end-to-end relationship here. What is the kind of relationship product and seller has? It's an end-to-end relationship, right? So we'll have to create a separate table, or okay, actually we will do it later on. So we can't remove these two. Seller to product and product to seller will still be there, correct? So we'll have seller to product. And then we'll have order to transaction, that will be there, correct? And we'll have customer to review. One customer can add a review, or what we can say is customer can add a review for a particular product. So product will have a review. So we can say that customer to product and product to review. It should not be customer to, yeah, it will be customer to review and it will be product to review as well. So let's put product to review as well. So can we say that because customer is associated with product and customer is also associated with review and product is also associated with review. So can we say that just we can have a relationship like this? We'll have a review for each of the product. And then finally order to product and product to order can't be removed, right? Because one order can have multiple products. One product can have multiple orders. So we'll need both of these relationships. Now, once you do this, then what we'll have to do? We have to, for many to many relationship, create an association entity. So let's see how do we do that. Let's see, this is one customer will have multiple orders, but one order will have only one customer. So we are sorted here. One order will have multiple products, but one product can be associated with multiple orders as well, right? I've actually mentioned it twice. I'll remove this from here. So one order can, sorry.
Can't we mention this directly by mentioning one and M, so that it would be easy to understand, I mean, which is one part and which is many parts, so that we don't have to mention both of them twice, I mean, such as.
No, but both of them are twice. Let me do it. Let me actually go to the Miro board. Give me a second. Let me know once you can see my board.
Yes, we can see it now.
Okay. Let me log in. Okay. Let's keep it simple. I mean, if that is, that is confusing. Let's try to see how to actually. So we have a customer table. Let's say that we have a customer table. We have a seller table. Then we have order table. We have product table. Okay. What else we have? We have transaction table. We have review table. Now let's try to identify the relationship. Can we say that one customer can have n orders and one order can be placed with one customer? So can we say that this is 1:1? Is this clear? One customer has n orders, one order will be with one customer. So basically this is always you put one here and then this is n. So this is why, that's why here we have n and one here and this is one. So that's why you put one here. Okay. Now one order can have multiple products, n product, and one product can be part of multiple orders as well, right? So can we say that this is n-to-1 relationship? Any questions so far? Any one of you? Now, can we say that one seller can be part of one seller, one order can have multiple sellers, correct? And one seller can be part of multiple orders. Now, can we say that one seller can actually have multiple products and one product can be sold by multiple sellers? So this is also in. Now one product can have multiple reviews and one review can be for only one product, right? So can you say that this is 1:1? Okay. And one customer can add a review for a particular product and one review can belong to only one customer. So can you say that this is 1:1? Correct. Now, what else we have? Transaction. So one order can have multiple transaction, but one transaction will belong to only one order. So this is 1:1. Is this clear to everyone? Any confusion so far? If there is confusion, then please ask. I'll stop here.
Yeah, Prakhar, how will handle this basket or cart one? I will store some status in the order.
We are saying that cart is on the browser itself. If you actually refresh the browser, cart will be gone. I mean, if you clear your cache, the cart will be gone for now. We are keeping it simple. We can create a cart as well, but we are keeping it simple. We can complicate it when we'll move to the actual design of e-commerce. Okay.
Sure. Thank you. Yeah.
I'm just trying to explain that the database design. Okay. So we have identified the relationships. We have identified the associations with each of. I mean, we have identified the relationships. Identify the entities. We have identified the relationships between these. Now we have to remove the redundant relationship. Now see which one is the redundant. So can we say that, see, customer can also associate it with the product, right? One customer can actually order multiple products. And one product can be ordered by multiple customers. Okay. Now see, we can associate order with product and customer with order. So can we say that this is a redundant relationship because customer will not directly talk to product. Customer will talk to order and order will talk to product. So can we say that this is a redundant relationship? So we remove this relationship. So let's say that we are saying that this one is a redundant one. So we are removing this one. This is not required. Okay. What else? So see, seller will always talk to product, right? From the product, you can figure out order. So can we say that this also is a redundant relationship? Correct. So let's remove these relationships. So now we have customer to order. So now the final relationships which you are having is, we are having customer. So let's write customer to order to transaction. This is 1:1. This customer to order is 1:1. Correct. Then we have to product. There's also this n:1. Then you have seller. This is 1:1. Sorry, n:1. And then we have review on the top. This is 1:1. One customer, one review, and one product. And this 1:1. These are the associations which are remaining, right? Now, whenever
Review can be of the seller as well, right? Cannot be of, always be of the product.
there's a
You
lot of
should-
background, there's a lot of background noise from your side. Can you please type your question? Yeah, I got your question. Review can be for a seller as well. Generally, we review for a particular product. We'll review for the product. I'll tell you how exactly this will be resolved eventually. Because we have an is-to-n relationship, we are saying that this is for the product. And generally, what we do is we actually give the review for a particular product. We are not giving the review for the seller right now. Okay. So here we are saying that we have the review for the product only. We don't have a review for the seller from the customer. Okay. Now, basically, whenever we have end-to-end relationship, we need to resolve these end-to-end relationships. So the way we do it is we create an association entity in between because see, we can't have one order can't have list of product and one product can't have list of orders, right? So we'll have to figure out another association which can actually relate these two entities. Same goes here as well. One seller, we can't put the list of sellers in the product and we can't put the list of products in the seller. So the way we do it is we actually create an association entity. So we say that for seller and product, can we introduce another entity called item? Now what we say is this item will contain product ID. This item will also contain seller ID. Correct. So we have created a separate entity for the product and the seller to remove this n:n relationship. Now, can we say that one seller can have n items, but one item will belong to one seller? Similarly, one product can have multiple items, but one item will belong to only one product. So that's why we resolve this. Similarly, we have order and product. So the way we resolve it is we say that, let's say we have order line item. So what we say is one order can have multiple order line items, which will have the order ID. And one product can have, again, multiple order line item. But one order line item will have one product ID and one order line item will have only one order ID. Is this clear to everyone? Please ask if you have any questions. Please type your question if you have anything. Yeah.
Can you explain the order line item?
I'll create the table. Don't worry. I'll explain to you again. So what we are saying is, so see what all fields you'll have in the order table. Let's see what all fields you'll have. So we'll store the order ID. We'll store the customer ID. Correct. We'll store the order ID. We'll store the customer ID. We'll store the total amount. We'll store the order status. Now we have to store the list of product IDs, right? Now this is a problem, right? Because we don't want to store the list here. Correct. So instead of storing the list of product ID, what we say is we'll actually denormalize this because this is a SQL database, right? So we denormalize this. We say that we'll create an order line item. And what will store is, here is order ID, product ID. And we can have a status for each of the line item, how much quantity you have bought, let's say. Correct. Now, instead of product ID, because we have resolved we might want to know the seller as well, right? So instead of product ID, what we can do is we can actually store the item ID. And because we know the item ID, we'll know the seller ID as well. So we have the item ID, quantity, at what price you have bought, and the status of each of these line items, right? Because this item might be delivered separately from the complete. I mean, you might not receive the complete order at the same time. Okay. And what will be the primary key of this table? The primary key will be order ID. You might have a confusion like, why did we actually go from a product ID to item ID? Because we might want to know the seller as well, right? And the way seller is resolved is through item. So we can always know in the item table, we are already storing what? In the item table, we might be storing what? We are storing the seller ID, product ID, and the price which they have defined for this item. And the primary key of this table will be what? Seller ID, comma product ID. Or product ID, comma seller ID, because we'll query more on the product ID. Product ID, comma seller ID. And what will be the primary key of this table? It will be order ID, comma item ID. So we can know for this particular order what is the item, and for this item what is the seller from. We can know the product ID as well, because see, here we'll have the item ID as well. I'm sorry, I should not put this as a primary key. It's better if I create an item ID separately. This is my primary. And this is the price. So that's how we resolve. So this was end to end, right? Order to product was end to end, and product to seller was also end to end. So to resolve this, first we created item, and we have item ID, seller ID, product ID, price here. And for this one, we said that we'll create an order line item so that this is 1:1 and 1:1. This doesn't remain n:1 because you can't store n products in one order, because one product can belong to multiple order, and one order can have multiple products. As soon as you have multiple products here, that's a problem. So that's why we created this table. Is that clear to everyone, or anyone of you has any question here? Why we need item and order line item? Item represents that. Okay, very good question. So order line item is defining that, okay, let me explain you. So let's say we have inventory. It's a separate service altogether, right? Now inventory will have products. Let's say you are selling only 10,000 types of different products on your platform. Okay. Now these products can be sold by different sellers, right? At different prices. Correct. So we'll have to store. See, product is a very specific thing, right? We know that, okay, we are selling rice. Now rice can be sold by, so rice is our product type. Now rice can be sold by multiple vendors, right? It can be sold by multiple sellers. So we need to store, right, these rice. So rice is like, let's say, product ID, but these rice will be sold by this seller ID at this price. So we'll have to store it separately. So we have created an items table, and in the items table, we are storing the product ID. Basically, the product ID will be the ID of the rice product, and we are storing the seller ID, and we are also storing the price, at what price they are selling. So that's why we have a separate table for item. Is this much clear, Sudhakar? Now the second part is when we create the order. So when we create order, so we'll have to store in one order. You can buy multiple products at the same time. Now you don't want to store the list of products in the same table, all the list of products in the same table. So what we do is, instead we create a separate table, because there is an end-to-end relationship. We create a separate table. We say that we have order line item. Order line item basically represents each of the separate items which you have ordered is a part of that particular order. So let's say if you have purchased 5 things, you have purchased 3 packets of Surf Excel, you have purchased 2 packets of some shampoo, you have shampoo bottles, you have purchased 3 packets of some biscuits. Correct? So biscuit ID is biscuit product ID of the biscuit will be one line item. The quantity will be another line item. What will be the price will be another line item. So this will be one particular line item. It will be associated with the same order ID. Okay. And the item ID is basically from which seller you are selling, which product you are selling. Based on that, you'll figure out the item ID, you'll put the item ID. Same thing goes for the shampoo as well, and same thing goes for your Surf Excel packets as well. Is it clear now?
Yes.
Anyone else who has any questions here? And don't worry, if it is not 100% clear, we'll actually, when we'll start designing things, we'll see more questions on this, and we'll be able to figure out how exactly, when to actually break our relationships. It's not very difficult. You will be able to easily do it, and like once you'll practice 1 or 2 questions. Okay. So this was about removing the redundant relationships, and for many-to-many relationship, we create an association entity. Okay. Now,
Prakhar, this intermediate table is associated table. Do we need in the NoSQL database as well, or it's related to only SQL database?
Usually, we do it when we are actually writing a SQL database. You can store the list of item IDs or list of products ID in the NoSQL database, and you can create an index on the top of it. That should be fine.
Correct.
Yeah.
Okay.
The NoSQL databases, you can actually store the list of products ID. It's just that it becomes, so NoSQL provides you to create an index. So basically, I'll give you why we have to create a separate table in SQL databases, because we might want to fetch all the item IDs, all the orders in which this item has been placed. Correct. So we can create an index on the top of item ID here. I'll explain the concept. I don't know if I've covered. Did I cover the concept of index in the high level design?
Yeah.
Covered it in detail, or okay, cool. So you understand, right? Why do we need an index on the item ID? Because we might want to keep this data sorted, and we might want to fetch all the order line items for this particular item. Correct. Now, see, that's why we have index in the item ID. Now, if you go ahead and create a NoSQL databases, your table will look like this. It will have order ID. It will have customer ID. It will have order status. And here, these are like key value pair. And here, basically what you are doing is, let's say this is my document DB, right? So this is my order ID. We'll put some order ID here. This is my customer ID. We'll put some customer ID here. We'll have order status. We'll change some order status here. Correct. Now, after that, we'll have another column called order line item. And we'll say that in this order line item, we have, it's an array. It's an array of what we'll have here. We can have item ID, the value of that item. So whatever is the value, comma. What we'll have after that? Price, quantity. We'll have some value here, comma. What is price per unit? So you will have price per unit. That will be price. We'll have total price. This is the value you have. Then we have the status. And we can track a separate status. And then this will be one row. And then you can have another row like this. not the row, basically same details again. This is like an array, another third one. So this is my order line item. And this finally, this array will be closed here, comma. We can have creation timestamps. We'll have creation timestamp here. We'll have the timestamp value. We can have update timestamp. We can have other fields as well. Like let's say order status. What is the total amount? We'll have to capture the total amount as well. Total amount, including shipping and everything. So we'll have total amount captured here. And then this is closed. Now see, when you do this in the NoSQL database, it will look like this, something like this. Okay. But in a way, you're not storing this, you're storing the array here, right? And what you can do is in the NoSQL DB, you can actually create an index on the top of this. So you say that index on order line item dot item ID. So if you create this index, as soon as you create this index, you can again fetch all the orders for this item ID. You have this flexibility to create an index on this field in the NoSQL DB. There is a way to resolve the array. First, you have to resolve the array, and then you have to go to the item ID. I don't remember the exact syntax, but you can create an index on the top of item ID. Understood? So this is the NoSQL database. For the SQL database, we'll follow this approach. It's more or less same thing. It's just that we have, just copied this table and we have put it here, and then this will become a comma separated one because this is now this, there can be an array and we can pass through the array in case of NoSQL data. Anyone who has any confusions or questions here?
So Prakhar, we don't need to maintain seller ID with item ID here, right?
We don't need to maintain it here or here, irrespective. Because we know the item ID, with the item ID, you can always figure out the seller ID, right? You have the index, you can figure out, we know the item ID, right? So you can always know the seller ID from the item.
Okay.
So that's the denormalization of the data.
Okay.
So now you don't want to actually keep the same data because see, item is associated with seller. You can keep the seller ID here but it is unnecessary, right?
Mm-hmm.
That's a normalization of the data. So basically you want to keep the seller ID because it's associated with only item. So we can always figure out from the item what is the seller. So why to keep it in this table?
I think this
that is
only denormalization only. It is going to be fast, right?
Yeah, I mean, see, that is something which is dependent on your requirement.
Yeah.
I mean, if you really need a seller ID to be stored in the order line item, then you can store it. If there is a use case to query send a lot of queries on that. If there is no use case, then why to denormalize the data unnecessarily?
Okay, okay.
The better, see, the benefit which you get with the normalization is, let's say tomorrow seller ID is changing. Now you can go and change the seller ID only in the items table. You don't need to change the seller ID in all the rows which are part of the product, because let's say there are 100 items which someone has item IDs with which you have done the purchase. The same item ID for 100 is present in 100 different orders. Now you'll have to go and modify all those 100 orders to change the seller ID. If you don't put the seller ID in the items order line item table, then you can just change the seller ID in case of item table, and automatically when you join the item table with this table, you will get the correct seller ID.
Okay, got it.
Sir, can you re-explain that point, please? I did not get it.
So let's say if you store the seller ID here. Correct. If you store the seller ID here. Correct. And let's say if you have 100 orders, let's say there is some item ID 1, 2, 3. Now let's say for this item ID 1, 2, 3, if the seller ID was to XYZ first, now it is changing to ABC for some reason, like seller has changed their seller ID. Just taking a random example. Right? Now, if ABC, it is becoming ABC, you'll have to go and modify all these 100 orders to actually change the XYZ seller ID to ABC seller ID. Correct. So it's
Yeah.
unnecessary modification of 100 different orders, right? In case of if you would have not kept the seller ID here, and if you would have modified this row from one XYZ to ABC, and whenever you associate item with this item, I mean join these two tables, then the seller ID, because the seller ID is updated only in one place, you don't need to update it in 100 places here because we are not storing the seller ID in this table. And that is the benefit. So that's an update anomaly rate. You might forget, because you have denormalized the data, you might forget to update the seller ID here by mistake. Then there will be a wrong data, because in this item table, you have seller ID is ABC. Here you have XYZ. And even if you update, you'll have to update 100 rows unnecessarily. Here you just need to update one row. That's why it's better to actually not keep the data as normalized as possible. Unless you have a use case to denormalize the data. What will be the use case to denormalize the data? If we'll have a lot of queries based on the seller ID in the order line item table, then it's better to put the seller ID as well as a part of that table. Because we don't want to perform the joins unnecessarily between the item table and the order line item table every time. Is that clear to everyone? I'm not sure if it is clear, but if it is not, then please ask questions.
What is the use case for denormalizing the stuff? I mean, you're saying that we need, if there are a lot of queries on the seller ID, okay, then you are planning to denormalize that particular stuff. But anyways, you will have the lot of queries on seller ID even in this case as well, right?
What I'm saying is, if you have to query order line item table based on the seller ID, then you will have to, every single time when you're sending this query, you'll have to join the order line item table with the item table. Performing join is a costly operation. So in that case, what we say is, we, instead of actually querying, performing the join between the item table and order line item table, just for the seller ID, we will start storing the seller ID in the order line item table so that we don't need to perform the joins between these two tables.
Got it. Got it.
So in cases where we need to query a lot, it's okay to do the data duplication?
It depends, right? Yes, I mean, it depends. And yes, you do it. Sometimes you need to do it because that will optimize for your reads. So basically the end goal should be that the latency of your queries should be as less as possible. Now, if you are reading that data once in a while, then it doesn't make sense to actually denormalize the data. But if it will improve your performance drastically, it will save you from join, it's okay to actually, it's okay to actually have the duplication of the same data across multiple tables. But during the updates, or you'll have to make sure that you are updating both the tables in those cases. So there are pros and cons, right? So either you optimize for read or you optimize for write. In case if you feel that it's better to optimize for read, then go ahead and have the denormalization of the data. If you feel that you have to optimize for write, then don't denormalize the data. So based on the queries, you have to take a call whether you should denormalize the data or not. Understood?
Yeah. So when do we get to know? So after we...
No, it depends, right? So when we are actually designing the APIs, you will know that what kind of queries you will have. Correct? You'll have to design the APIs. So once you design the APIs, you'll know that actually I'll query a lot of times on the order ID or not, or the seller ID or not for this table. If you're querying a lot of times on the base of seller ID on a particular table, on the order line item table, then put the seller ID in the order line item table. Let's say if you want to fetch all the seller IDs, all the order line items for a particular seller, then ultimately you'll have to go to the order line item table to figure out that detail, right? So it's better to put the seller ID in that table. But will you have a query where you will have to actually get all the order line items based on the product? Maybe not. So don't put the product ID in the order line item table.
Okay. Okay. So at the time of API design, we'll get to know what we are going to query a lot.
Yeah, I
Then
mean, you know what are the types of what are the read queries, right? And based on that, you will. So the way you create index only when you have a lot of reads on that particular data, right? Otherwise, you don't create indexes unnecessarily because indexes are costly. It will increase the latency of write. Same thing with the denormalization as well. When you know if there is a lot of read queries on that particular data on a particular table, and every time you have to join the two tables to get the data, then it's okay to actually denormalize some of the data in the other table.
okay, yeah, makes sense. Thank you.
Anyone else who has any confusions or question here? Okay. Shall we move on to the next part? So this is about the database, basic database design. Now, how to select between the SQL database and NoSQL database. I don't know if I've talked about it or not earlier, but let me give you some context again. So basically, you try to use the SQL database wherever you see a very structured data, and the data is not, I mean, you won't end up adding a lot of columns with time in your table. Then it's better to use the SQL databases in those cases. When you have a very non-structured data, by non-structured data, I mean is, I don't know if how many of you are aware of the trie structure. So basically, there is a lot of hierarchy in data. So it's better to use NoSQL database in those cases because you can't maintain hierarchy easily in the SQL database. Or let's take another example where you have to store all the connections. You need to figure out the first level connection, second level connection, third level connection in LinkedIn. If you try to store these details, like this person is associated with this person and this person is associated with some other person, and if you have to find the connection, it becomes very difficult. So in those cases, you end up using the NoSQL databases, something like a graph database. Correct. So, or let's say if you are getting a lot of logs, and if you can't make any sense out of those logs right now, and you know that the number of fields will increase up to thousands in future. You don't know how many fields will be there in this table. It's better to actually use the columnar database, which is again a type of a NoSQL database in those cases, because it will be a very sparse kind of a matrix where for one particular row, only 4 or 5 fields are populated, but there are thousands of columns. So it's better to use the NoSQL database in those cases. In general, what I've seen is most of the companies prefer to use SQL databases because they have expertise, engineering expertise in those areas. Also, it depends on the kind of requirements you have, right? Like in NoSQL database, it's easier to actually, do the analytics. It gives you some of the functionalities like consistency and availability. We have talked about CAP theorem, right, in our previous, in one of the sessions previously.
Yes, yeah.
Okay. So if you remember in the CAP theorem, we talked about consistency and availability and partition tolerance. So we have mentioned that you can't get consistency, availability, and partition tolerance all together. And in a distributed system environment, you need at least the partition tolerance. So you can either choose a consistency or availability between in a distributed system environment, because you'll always need a partition tolerance. Now, NoSQL databases actually provide you, I mean, you can choose either the consistency or availability out of the box, because they'll make sure that the partition tolerance is already enabled in the NoSQL databases. In case of SQL database, you'll have to actually write your own code to have the partition tolerance. You don't get the functionality of partition tolerance and consistency and availability out of the box. So if you have to write your own code to make sure that you choose either the consistency or availability along with the partition tolerance in the SQL databases, and that code has to be written on the application. So there are some pros and cons of using the SQL and NoSQL databases. Generally, the way I decide to go ahead with the SQL DB or NoSQL DB is based on the structure of the data. If I feel that the structure, the data is well structured, then I prefer to go ahead with the SQL DB. If I feel that the data is not well structured, then I prefer to go ahead with the NoSQL databases in those cases. I'll stop here. We'll take a break. I would like all of you to actually, I don't know if you people have the link to this Miro board or not, but I want all of you to quickly go through this Miro board. and make sure that you understand how did we actually create the relationships, how did we remove the redundant relationships, how did we figure out the entities, created the relationships, then remove the redundant relationships, then created the association entity if it's an end-to-end relationship, and then finally normalize the data. And if it seems complex at this point, don't worry. Once you start practicing 2 or 3 questions, we don't need to actually go through each of these steps separately. You'll be able to do it on your own. We'll just directly draw the one-to-one, end-to-one relationships, and we'll just see how many of these relationships can be. If it's an end-to-end relationship, how to design the association entities. I mean, to be honest, we know that we won't have a product customer ID in the product table, and we won't have the product ID in the customer table ever. It will always go through the order. So it's unnecessary to actually create that link. But because these are the 5 steps generally which are recommended to design any complex database design, that's why I walked you through it. But once you start doing the design, then we don't need to explain to the interviewer that we are actually taking these 5 steps, and we will reduce it to 3 steps, and you will be able to come up with a design on your own. So I mean, we'll cut short the step where we were trying to actually remove the redundant association relationships. We'll not even draw that, because we always know that customer is associated with order and order is associated with product. So we don't need to draw a line between customer and product. Same thing with seller is associated with product and product is associated with order. So we don't need to draw a line between seller and order. So you'll understand once you'll start solving more questions. That should not be very difficult. So yeah, please go through the Miro board. And if you have any questions, then please ask your questions. Otherwise, we'll move on to the next part. By the way, please let me know if I've explained you the indexing properly or not. If not, then I'll walk you through the indexing again, just to make sure that you understand the indexes properly.
Yeah, please recap that indexing concept, please.
Have we covered indexes in detail in past?
In the very first design for the Twitter, we very briefly talked about that, but it was not in a full detail.
Okay, let's cover indexes once again. I'm not sure what all things I've covered, but just to make sure that you understand the index, because again, it's a very important concept. I'll just explain the indexes. Okay, if there are no further questions, then let's move on to the next one. Cool. So now we have figured out all the relationships. Now let's try to understand clustered and non-clustered indexing. Let me actually put one example here. It will be easier for me to explain. Cool. Let's go back to our document. So there is something called cluster or non-clustered indexes or primary or secondary indexes. Either of them is fine. What is clustered indexes? It's the index on which sorting is performed on the table. By default, there can be only one clustered index. Okay. Or you can call it as a primary index as well. If the primary key is defined, then the cluster index is created on the table. What does this mean? So let's say we have an employee table. In this employee table, we have employee ID, correct? So employee ID is my primary key. So automatically database will create a primary index or a clustered index based on this table. And sorry, based on the primary key, and all the data in this table will be sorted based on the primary key. So you'll have 1, 2, 3, 4. So you can directly go to the row number 3, and you can, if there is a primary key defined, and if we have a query like select star from table, employee table, where primary key, where employee ID equal to 3, the database doesn't need to do a full table scan. It will store the data in the disk in such a way that it will know at which particular, which particular disk. So there are multiple parts of there is a sector and the segment. So in which sector, in which segment the data is present, and it will directly read the data from here. Simple. Now, in this example, employee ID is a primary key. It will automatically act as a cluster index. So we'll have 1 row number, 2 row number, 3 row number, and 4 row number. Correct? The output of this code will produce in increasing order of the employee ID. Done. Correct? Now, for the non-clustered indexing, the index is sorted, but the data might not be present in the sorted order. Index are sorted separately and stored separately. Correct? So for example, in the above case, if we actually create an index on the basis of employee name, the way it will store the data is it will sort these values. It will maintain a separate index table like this, and this will have sorted data like Alice, Bob, David, and John. And Alice will actually point to the row number 4. Bob will point to row number 2. David will point to row number 3, and John will point to row number 1. And let's say if we are getting another name, let's say we are getting someone as Don, then Don will come after David, and Don will again. So here, let's say that will be employee number 5. So 5 here, the row will be added as 5. We'll have Don as another entry. There will be some employee number, and there will be name. And now, basically, because this is a sorted index, the data is sorted on the basis of the employee ID. You'll have the row number 5 here, but at the same time, the index will also be updated, and Don will come after David, and here it will point to row number. Basically, whenever you'll update the table or change the values in the table, accordingly your indexes will be modified, and the indexes will be sorted based on the field on which you have created an index. So here we have created an index based on the name. So the index will be sorted based on the name, and it will start pointing to those rows which are present in your table. Any questions here? So when we write select star from employee, where employee ID, employee name equal to this, and employee ID equal to this, and employee address equal to this, automatically here, let's say we have created a primary key based on this. We have created a non-clustered index based on this, and non-clustered index based on this. It will have employee name and employee ID, right? So it will automatically optimize for this query, and it will actually use this primary key. But for example, let's say we don't have employee ID here, then it will actually, what it will do is it will automatically see that there is an employee name and employee ID. No, that's not what I meant. Remove this. So let's say if you have created a non-clustered index based on the employee name and address, then it will automatically figure out that we have an index based on the employee name and address. And it will directly, based on this particular index, it will query the data and return you the data for this particular query. So basically we have the index based on the employee name, right? So first it will go to employee name, and there can be multiple same names, right? So then it will go to employee address. So the way the data will be sorted will be, first it will be sorted based on, so these are the composite indexes. So in case of composite indexes, let me write it. In case of composite indexes, the data is sorted first on the basis of the first key mentioned as a part of the index, then second key, and so on. Let's take an example. Let's go back to the Miro board. I'm not sure how many of you understood this. So let's go back to the Miro board and let's try to understand this in a better way. So let's say that we have created a table. Let's say we have created an employee table. So we have an employee table. In this employee table, we are storing employee ID, which is my primary key, name, city to which they belong. We are storing name, city. We are storing their phone number. And let's say we are also storing their age. So let's say we have employee ID 1. There is name as XYZ. City is Bangalore. Some phone number. Age is 23. ABC, Alice, Bob, John, David. Let's call this as Don. You have Bangalore, Hyderabad, Bangalore, Mumbai, Delhi. You have some phone numbers associated. We have age. Okay. Now this is my primary key. So the first index will be based on this. This will be my primary index or clustered index because the data is sorted based on the primary key. So we can call it as a primary index, which will be by default created by the database. You don't need to create it on your own. Now let's say if you want to know all the employees for a particular city. And we know that there will be a lot of frequent queries based on this particular type. So if you want to know all the employees belonging to a particular city. So what we do we decided to actually create an index on the top of city. Now, if we create an index on the top of city, the data will be maintained in a sorted order, as I mentioned. So first we'll have Bangalore, then we'll have Delhi, then we'll have Hyderabad, and then we'll have Mumbai. And this will be pointing to this row and this row. This will be pointing to this row. This will be pointing to this row. And this will be pointing to this. So when we say that give me all the employees for Bangalore, because we have an index, it will know that these are the two rows for which I have to fetch the data. It will go and read these two rows. If we don't have this index, then you'll have to do the full table scan. Now let's say we create another index based on employee age, comma city. So there was a requirement that you need to fetch all the employees whose age is lesser than 25 and are from Bangalore. So, and we know that there are a lot of queries like this. So we create an index on the basis of this. So now the way data will be sorted will be, let's say this was 28. So the way data will be sorted will be first based on the employee age. So what is the employee age? Smaller is 24. And then employee age. And then for this employee age, what is the city? Correct. So first the data is sorted on the basis of the employee age and then on the city. So we have 24 and 24 here. Then we have 25 here. And then we have 28 and 28 here. So if it was supposed to be just based on age, then this would have been indexed. But if the age is same, then you have to sort the data based on city, right? That is the requirement. So if the age is same, so 24 and 24 has the same age, correct? Then we have to sort it on the basis of what? City. So what we'll have? We'll have Bangalore first. And then after that, what we'll have? After that, we will have Delhi. In 25, we'll have Mumbai. Simple. For 28, we have Bangalore and Hyderabad. So we'll have Bangalore first and then Hyderabad. Now basically our query to get all the employees who have the lesser age than 24. So you can directly query just based on this particular employee age and you'll get this particular chunk. If the query is give me all the data based on for this particular age group where the city is Bangalore. So if let's say it is for 24, then you can directly go to 24 and you can always know that for Bangalore, this is the row. I'll fetch this particular. So is this clear? So you can either, so, and if I create it on the base of city, comma, employee age, the way it will be done is first Bangalore will come, another Bangalore will come, and then first 24 will come, and then 28 will come, and then Mumbai will come. No, not Hyderabad will come. Then Delhi will come, and then Hyderabad will come. So for Hyderabad, this will become 28. This will be what? 24. Sorry, for this was Mumbai. Sorry. My bad. So for city, comma, age, we'll have Bangalore. Then we'll have Delhi. Then we'll have Hyderabad. And then we'll have Mumbai. And Bangalore, Delhi will be what? 24 again. Hyderabad will be 28 and Mumbai will be 20. That's how the data looks. This is another index which you have created. You understood, right, how the data is sorted based on the index. Anyone who has any questions or confusion here?
Yeah. So we can either create index for one column or a combination of columns, right?
Yeah, I mean, that depends on the kind of queries you will get again, right? As I keep telling you, you create the indexes based on the kind of queries you will receive on your database. Mm-hmm. You don't create indexes unnecessarily because indexes are always costly.
Right, okay. Right. Another question is, let's say, for example, we created index for the combination of employee age and city, the one on the right? So then with that index combination, can we also search for age using that index?
Yeah. So you can use just, if you want to search based on the employee age, then you can use this index. Okay. But if you are saying that you want to search based on the city, then for the city, at least you need to know the employee age, right? Otherwise, how will you fetch the data? See, because Bangalore and Bangalore are appearing at different places here, right? So you can't
Yeah.
you can't use this index just to search based on the city.
Okay.
You need to have employee age along with the city to use this index. Otherwise, it
Okay.
will do a full table scan, right? Because see, Bangalore and Bangalore are two different places. They are not existing together. So you don't know where exactly Bangalore is existing. So you have to do a full table scan. Understood?
Right.
In
Right.
that case, you should prefer this particular index where you have the city here. So you'll know that this is the city for which I have to fetch the data. Then in that case, this is the preferred index over this index. Understood?
Right. So the index on the right for employee age and city, if we try to search on just the city, then this index is not usable, right?
You'll end up doing a full table scan.
Right. Right. So instead of doing the index by combination, can we do two separate indexes for age and city separate, and then can we
You
use
can
this
do
a
that. You
combination?
can do that. You can do that. But then in that case, you can't actually, you can't. So if you use two different indexes, right? I mean, see, in one query, you can only use one index to optimize. You can't have two different indexes to optimize, right?
Right. Right.
So if you have a query where you have to search by employee age and city, then in that case, you will create a combination of index, but you can always actually use the partial index to query the data. For example,
Okay.
if you create employee age, comma city, then you can use employee age to query the data. It will optimize the query for you. But I mean, if you have, let's say, employee age and city as two different indexes, then your database, and if you have both the fields present as a where clause in your SQL query, then your database will figure out which index is better, whether it's an age index which is better or employee city index is better. And based on that, it will automatically optimize your query, but it will only use one of the indexes, not both the indexes to optimize the query.
Okay.
Understood?
Yeah. Yeah. Makes sense. Thank you.
One question, Prakash.
Yeah.
When you're querying the data, say for
Jinesh, there's a
example,
lot of background noise from your side. Can you please write your question? I mean, I don't know why, but there is a lot of background noise from your side. Yeah, I mean, the recording experience is not good, and that's why I don't prefer, like, I mean, you can ask a question, you can put it on the chat. It becomes difficult to answer. Also, I mean, the recording won't be good, and that's why please, it's a request if you can type your question or make sure that there is no background noise from your side. I'm sorry. Anyone else who has any questions here? Okay. Jinesh, feel free to type your question. I'm happy to answer. It's just that there's a lot of background noise. I mean, the recording is not good at the end. Okay. So this is about this is about the indexes. Now let's try to understand some of the properties which are provided by the SQL database. And it is very important to for you to understand these properties, because based on these properties, it will be easier for you again to make a decision whether you need to use a SQL database or not use SQL database. So the question from Jinesh is, when we are querying the data, do we need to query in the same order the index has been created? No, that's not true. So basically, database will automatically figure out what is the index. So basically, you don't need to, you can directly write a simple select query, and your database is intelligent enough to do the query plan on the top of it before it executes the query, and it will figure out which one is the best index for the query which you have mentioned. You don't even need to mention the index which you're using for this particular query. If you mention a particular index, then it will, even if you have a better index, then in that case, database won't optimize, and it will query on the basis of that index which you have mentioned as a part of the query. In general, that is not recommended. You can leave it up to database to figure out which is the best index for you to actually optimize the query. And it will, or you put where, and then on the basis of the where, it will figure out what are the values, and it will automatically optimize the query on the top of it, and it will choose the best index possible and return you the data. The second question is, an order by clause is not in the same order. See, order by is a different thing altogether. Order by happens once you actually get the data. So the way, let me go back to the doc, the whiteboard. The way the queries are executed is, first the where clause is executed. The first thing which is executed is the from clause. From which table are you want to execute? Then we execute the where clause. Then after that, you actually uh, execute the group by clause. Once you execute the group by clause, then you execute the having clause along with the group by if there is any. Once you execute the having clause, then you execute the select clause. Once the select clause is executed, then you execute the order by clause. So in this order, your query is actually executed. So first, index is applied when you are on the where clause. Okay, so irrespective of the order by which you are trying to, view the data. Indexes order by doesn't play any role to select the indexes. Once you select the data which you want to query for, once you select the data which you are querying for, on the top of it, after applying all these clauses, order by clause is applied just to sort the data based on the base of which you want to view the data. Is that clear to everyone? Any questions here? Cool. So please remember this order. It will actually help you to understand help you to write the correct queries as well during your interviews. So you start with the from clause, which is your table. Where clause, where you actually filter out all the fields on the basis of which you want to get the data. Once you get the data, you group by that data. You apply the having clause on the top of it, which might remove some of the data. Finally, you select that data which has to be displayed, and you order by it in the order in which you have to view in the order in which you want to view the data. So that's how the query execution works or happens. Okay. There are no further questions. Let's move on to the next part. We'll try to understand what are acid properties and why actually it is important to have acid properties in some of the. There are a bunch of things which I have to cover. Let's see how much things you can cover. Today it's a part of the database design. Let's go through the acid properties. Let me actually go back to our doc. Yeah, let me know once you can see my doc. Okay. Now we are talking about acid properties. So there are acid stands for atomicity, consistency, isolation, and durability. Let's try to understand what is atomicity, consistency, isolation, and durability. So atomicity means that there are no partial updates in the transaction. Either everything will be updated or nothing will be updated. So it's always about all or none. Like all the details will be updated. So let's say if you have created one transaction, and in that particular transaction, you're trying to update two tables at the same time. Let's say you're trying to update the table 1 and table 2, or let's say if there are two tables, let me try to think of a better example here. Okay, let's say we are actually updating the transaction table and the order table at the same time in the single transaction. Because the transaction status has changed, you might want to change the order status as well. So what we are saying is, when we try to update the transaction and when we try to update the order, we are trying to update both of these as a part of the same transaction. So either both of these fields will be, both of the fields in both of these tables will be updated, or none of them will be updated. So this is known as your atomicity. Each of the operations are atomic in nature. So either everything will be updated or nothing will be updated. No partial updates in a particular transaction. Consistency means that the database and the application are responsible. Basically, the database and the application layer are responsible for maintaining the consistency by with the help of transaction. So what it means is, let's say uh, the if the database was in consistent state before a particular transaction, it should remain in the consistent state after actually executing the transaction. For example, let's say you have a bank account, two bank account present in one particular table, and you're debiting the amount from one table and crediting it into the debiting the amount from one account and crediting it into another account. So the state of the database should always remain consistent. So for example, let's say earlier you had 100 rupees on account A and 100 rupees in account B. And if you have transferred 20 rupees from account A to account B, then the sum of the amount should still remain same. So now the account A will have 80 rupees and account B will have 120 rupees. It should not happen that the amount is debited from the one account, but it is not created yet into another account. So the database should always remain in a consistent state after executing a particular transaction. Is this clear to everyone? Now there is isolation. What isolation means is that if the multiple transactions are occurring concurrently without leading to inconsistency in data, then those transactions are executed in isolation. Changes occurring in the other transaction should not be visible with the in the other transaction until it is committed. For example, let's say you are reading the data here and you are doing x equal to x plus 1, and then you are writing the data, but you have not committed x. If you go and read the data in the transaction 2, it should be 42 only because you have not committed this data yet. And if you do x equal to x plus 1, and then if you write the data, it will be 43. But when you commit this data, it will become 43. When you commit this, ideally this should fail because you are trying to update the same entries. But let's say if these would have been two different entries, y and y, x and y, then these transactions can happen in the isolation without one transaction changes visible to the other transaction. Even if these two transactions are happening on the same value, if you will see here, unless this is committed, the read of x is still 42. Now, will it lead to inconsistent data? It might lead, I mean, if you actually execute both of these two transactions, then it will lead to inconsistent data because the value of x should be 44. But when you commit x here, it will be 43. And if you commit x here again, it will be 43, which is wrong. To handle this, basically, we actually use the locking mechanism, and we'll talk about the locking mechanism soon. But what I'm trying to say here was that if there are two transactions happening parallelly, even in the on the same values, then the changes in this should not be visible on this. Correct? But it doesn't, I mean, basically what it means is if you read x here, it should not give you 43 unless this value is committed. Because what can potentially happen is that if you before you commit this data, something fails. If you have written it and if you're trying to do something and if something fails here, then you end up reading a wrong data here. Correct? You will read 43. So because it is not committed, the x value is not changed. And if this transaction read a non-updated data, then you might end up committing 44 now. Ideally, because this transaction was failed, ideally the value should be 43 only. Correct? Now here what is happening is here when we are trying to commit, we are writing the wrong data. To handle these things, we are using the locking mechanism, and we'll come on to that. But what isolation says is that even if multiple transactions are occurring concurrently, it should not lead to the inconsistency in the data. Also, changes in one transaction should not be appeared in the other transaction unless the transaction is committed. Okay. And the last part is the durability. When you persist the data whenever the transactions are committed, and you make sure that you have enough backups, the data is durable. Basically, you should be able to always roll back your data to the previous committed state. So you persist the data whenever the transactions are committed. Now there should be a read and write lock mechanism on the above example. Why? Because we don't want this data to be updated to 43 when we are committing this, right? This is a separate transaction. So for the same reason, we use locking mechanism, where where we say that we will read X, correct, and we'll read X here, and when we try to apply write, there should be an exclusive lock, and no one should be reading this data. So basically we will force this particular transaction to leave the lock, and we'll fail this transaction. We'll upgrade this lock to write lock. The commit will happen, and again this particular transaction should again read the data again. Once it when it reads the data again, it will read the value as 43 instead of 42. Correct. Now there can be a situation where at a given point there can be multiple read logs, or there can be only so this is the standard way to actually update any data if there are multiple transactions. So what it says is that at a given point there can be multiple read logs, or there can be only one write log. You can't have one read log and one write log together. You can't have multiple read logs together. You can have multiple read logs together. You can have only one write log at a time. You can't have read and write log together. You can't have multiple write logs together. So there can be there can be a situation of deadlock sometime. How? So let's say read is happening on X, T2 is also reading X. Now T1 wants to write the data, and T2 also wants to write the data. So here there is a deadlock, right? Because unless T2 leaves the read log, T1 can't take the write log, and unless T1 leaves the read log, T2 can't leave the write log. Sorry, can't take the write log. So basically this is a deadlock. Now to handle the deadlock, what we do is there are different algorithms. We have aging mechanism. What we do here is we say that we read T1, we read T2, we have to write T1. So we force T2 to leave the log. So T2 will leave the log, read T2 is gone, we'll do write T1, we'll commit T1, then we'll read T2, then write T2, and then commit T2. That's how it's executed sequentially. Now to maintain the isolation, consistency, atomicity, and durability, we avoid the dirty reads. Read the data only when it is committed, as I mentioned. Avoid dirty write. Overwrite the data which has been committed. So we actually, to overwrite the data, so this is automatically, this is what you are discussing, right? Unless the data is not committed, we won't read the data. So this is your isolation property. Then avoid dirty write. What is avoid dirty write? Overwrite the data which has been committed. So basically, if you try to overwrite this data here, right? In this example, if you have write X, and if you again commit X and again perform commit X, the value should be 44 ideally, but you will end up writing 43. So to actually make sure that it doesn't happen, you either use a read write lock mechanism, which we just discussed, or we will use a serial execution. So we say that on one data, only one thread can execute at a time. So this transaction can't be executed on X unless this is committed. But that's a bad way, right? Because we might not want to update anything. We just might want to read the data. So you can read it here in both the transactions together. Okay. So that's why we prefer read-write locking mechanism, where we say that read log is a shared lock. Multiple read logs can be taken on a row at the same time. Write lock is a mutex lock. Only one write log can be taken at a time. If there are deadlocks, then preferred based on the aging and other parameters, we can actually, ask one of the transaction to leave the lock, perform, complete one transaction, and then other transaction can start. Now there is something called optimistic locking, where you actually don't take a lock, and let's not go into the details of this. This is very complex. I can explain you, but I don't think anyone will ask you these questions. Let's skip this. But we have 5 minutes, so let me explain you. I mean, it's not urgent. It's not compulsory for you to understand everything, but let me try to explain. If you can, it's good for you. So what is optimistic locking? So optimistic locking, it is something which came up very recently in all the databases in last 5-6 years. And all the databases, the new databases have moved themselves to an optimistic locking. So what it says is that I won't take actually a lock. So that the transaction won't take a lock when we are reading the data. It won't take a read log, it won't take a write log. We will actually, when we are committing the transaction, we will check if the value has changed, apart from the changes which I have done, if the value has been changed between the time when I've read the data and when I'm committing the data, apart from my changes, if that is changing, then I don't perform the commit. If that is not changing, then only I perform the commit. The benefit is basically, let's say if I am reading the data and I want to write the data and you just want to read the data, with the current approach, I can't write the data because you have already taken a read log. So there is a deadlock. With optimistic locking, what will happen is I have taken a read log. I haven't taken a read log, but I have read the data. You have also read the data. You don't want to perform any write. So your work is done. You're done. You have completed your work and your transaction is done. You're not writing anything. When I'm trying to write the data, I'm checking if the value has been changed from the point where I've read the data till this point. The value has not changed. So then in that case, I can commit, right? So I don't want the transaction 2 to leave the read log to perform the write now, because I'm not even taking the read log for the transaction 2. Now, when the transaction 2 has read the data and if transaction 2 try to perform the write, it will see that the value has been changed from the point when we have read the data, apart from the changes which I have made. So automatically that transaction will fail. So now this helps you to avoid the deadlock situations. You don't need to perform any aging. You don't need to perform any deadlocks. Whichever transaction is committing the data first, that data will be considered. Also, the transaction doesn't need to wait for someone other transaction to leave the read log, because we are saying that we are doing the optimistic locking. We are saying that consider that we have taken a log, and if something has changed between my read and my write, then I'll fail the transaction. If nothing has changed, then I'll commit the. Understood the optimistic locking or no? It's not clear. Any one of you who has any questions here? I know like I have shared a lot of details today about the database design, but I mean, these are important things and it's good if you know that these things, even if they are not directly asked in the interviews, because I mean, sometimes you might get a question which is based on one of these logics, and then you should be able to answer these questions, right? And it helps you to actually design your system in a better way, and your interviewer can ask you questions, but it won't be that free. I mean, you won't get a lot of questions on the topics which you have discussed, especially the optimistic locking and acid properties. But it's always good to know these things because you're actually working on some of your applications in your company, and you should be able to figure out, I mean, you should be able to figure out like what should you do to actually handle some of the corner cases, how to create the table. You should know if you're doing something in the transaction, then it should be committed together. You should understand the acid properties. You should have the understanding of the indexes, and especially indexes, because indexes you'll have to create on your table whenever you're actually appearing in the interviews as well. And it's good to have the right set of indexes on your tables and don't create unnecessary indexes, because it will increase your write updates. But if you really need an index, then you should create it, and I explained you the way in which you should create the indexes. If you are creating a composite indexes, then how your index should look like. It's good to know all these concepts, and your interviewer can definitely ask you questions on these things. Question regarding index. If you have index on the city and name, and if you have created the two separate index on the same, it won't allow you to create two separate index on the same. You can't create an index on city comma name. You can create city comma name and name comma city. Correct? You can create those index. Then when you're using the where clause and use the same column in where clause, then where these separate index will be useful, or it will be always. No, it won't be full table scan. So
We have a separate index on the column. Right?
Yeah, then in that case, it will use one of the. You have two separate indexes, right? That's what you're saying.
Yeah.
If you have two separate.
Say for example, index on city and name, okay. And then
if you have two separate indexes, one on city and one on name, and if you put both the fields in the where clause, then your database will optimize. It will see which index is better, and accordingly, it will pick one of the indexes. You can't have, it won't actually query based on the two indexes. I already told that. I already explained that, right?
Okay,
Did you
thanks.
understand?
Yeah, got
Did
it.
you?
Yeah,
You
got it.
can't use two indexes at the same time in query. So database will figure out which index is better, whether it's a city index which is better based on your query or the name index which is better based on your query, and it will pick one of the index and it will automatically execute the query.
I
Okay.
think I have one more question regarding the replication. I hope there is no background noise from my side this time.
Go ahead. Go ahead.
Uh, there was a case you have explained that async plus sync writes. Okay, there are synchronized writes. There is an asynchronized write. Then there is a combination of async plus sync, where you are saying that there would be based on a certain say you for a certain user when the request is coming, we might be maintaining the mapping where it will be the data won't be copied to all the slave nodes, but to a certain set of slave nodes, and we'll write a success as a write a success. Okay.
Yeah.
So in that particular case, how you are, and then the rest of the nodes you are saying that use as per the lecture, what has been mentioned is that when there is a, I mean
Yeah,
the rest.
I remember. What is the question?
So what would be the criteria for the mapping? Okay, when you're saying the mapping, it would be based on a user or it would be based on a request. And how you're going to do that? I mean, say for example, in one particular database, if I consider I have two or maximum, I have two or three users, let's say, okay, so then uh, how, so there would be mapping for only those three, or it would be combination of both user and request you are going to maintain the map, so that the next time when you are getting the data, you will get it quickly. You
So
got
it's
my
not based on the request for sure. The way it works is that basically you're updating the data, right? So basically it will be based on the user ID. So the field which will remain constant in every single. Can you go on mute, please? It will be based on the every single. Yeah, it will be based on the every like the field which will remain constant after a particular request. If it is on the request ID, then you won't get the same request ID again, right? So for example, it's based on the user ID. So you try to write something. So when you're writing something, you know that I have updated the data for this particular user ID. You are maintaining a lookup. So you actually look up based on the user ID in what all applications I have the data. It's more like a snapshot. So you say that the data is present in this and this and this machine right now. So if there is an update request, you'll go and update it in those same machines only. In some of them, in let's say if you have 10 machines, if you have written the data successfully in 3 machines, asynchronous data has not been written yet, then next time when you get a request, you will go to those 3 machines and write the data in those 3 machines only. If the data is written successfully in 10 machines, you will pick any of those 10 out of any 3 machines out of those 10 machines and write the data on the top of it, and you maintain it in your lookup table. That's how it will work. So it
but
will be based on the user ID.
but in that particular case, uh, what would be the, you're saying we are maintaining based on a user, right?
Yeah, correct.
We are maintaining based on a user, right? So you're saying the data, I mean, what data would be what? I mean, say for example, I'm writing, I'm in a one particular transaction, one particular user is writing in a 7 tables. So if we go by that particular
This is
route,
per table. This is per table lookup, right? So you say that I have updated the data in so and so table for
okay,
so and so user ID. So next time if you read the data, you make sure that you read the data from here, because my asynchronous, I might not have copied the same data in all the other tables yet for this particular user.
got it. Thanks, Prakash. I got it.
Understood?
Thank you.
So next time when you're getting the read request, you know that this is the table for this particular user and these are the machines from which I should read the data from now. And
So that we are maintaining that particular thing in a for a per
lookup
table basis. So if
in a lookup.
in a transaction, if I'm updating 7 tables, then there would be a separate entry for those 7 tables for that particular user, right?
That's good. That's good. Yeah.
Right.
It's more like a lookup thing which you are maintaining here.
Thank you.
Okay. Now we are done with the database design. I would request everyone to go through all the concepts which we have discussed today. And tomorrow we'll start with a low level design where we'll try to take some questions like library management system design, hotel management system design, e-commerce design. And we'll try to work on this, and I'll give you some, basically some homework as well so you can practice on your own. But for today, I would request all of you to actually go through this and try to understand the database design properly. And if you have any questions, then please ask your questions in tomorrow's session. And then we'll start with the low level design. And I'll explain you how to actually come up with the classes, the entities, the fields in those classes. We'll talk about all those things in tomorrow's session. Also, I would request everyone to join on time by max to max 8:20. I'll start class by 8:20. It's a request, humble request for everyone to join on time. Thank you so much. See you all tomorrow. Yeah. Bye. Yeah,
So-
I'll end the session now.
Oh, okay. So let's say, for example, we have some aggregation or counts on the database, right? So in that case, we have to scan through all those.
So that happens after the group by clause, right? So you don't need
Yes.
to. First, the where clause will happen, and then group by will happen. You can do count only when there are group by, correct?
Yeah. So even after filtering, whatever is filtered, we still have to go through every single one of them and then do the aggregation.
We don't need to. So first you do the where. Once you have done the where, you will actually have the set of details which you have to work on. After that, you will have a group by. So you'll group by the field, particular field. So the data will be grouped by that. Having will remove that data. If you're doing sum, then when you're doing the sum, then automatically when you're doing the group by, it will sum the data for you. And you select that data. Understood?
Yeah. So let's say if whatever the queried results are in maybe few million records. So every time maybe we do that query often. So do we store that value somewhere in a separate table?
No. So I mean, database might optimize some things for you. If you know that there are very frequent queries, then database does some optimization. Some of the new databases does some optimizations. Basically, if you query the same data again, you might see that the data, like the result returned, are faster than what. So when you query for the first time, and if you write the same query again on the database, sometimes you'll see that you will get out data faster. I think some of the databases does some caching to optimize the queries if they see the same query again. But I mean, in general, there is no concept of caching in databases. Some of the database do that, but it's just purely based on the queries. It's not based on the new view which the database is created.
Okay, understood. Yeah. Thank you.
Okay, cool. Thank you so much. Bye. Have a nice day. See you all tomorrow.